Hello friends, this is Durga again from ITversity, a one-stop shop to learn all the technologies. At this time we are talking about Hadoop and especially setting up using Cloudera. And as part of this video I will try to cover what is HDFS and I will review the steps again to set up HDFS while explaining the architecture. We have already added HDFS as a service on our Cloudera. 4-node cluster using virtual machines. As part of this video, I will try to start explaining the concepts and then try to map the steps again we have done while setting up the cluster. Okay, so if you go back here, first let us understand what is HDFS. HDFS is Hadoop distributed file system. It is all about storage. And the file system is logical. It is logical because if you try to save a file in HDFS, physically it will not be saved anywhere with that file name. It will be saved as blocks. You will understand what those blocks are. So the physical component that will be used to store on the cluster is called as blocks, and a file, whatever name you have given to it, will be split into multiple blocks and it will be distributed onto multiple data nodes in the cluster. We have a cluster with the 3 data nodes, and if you try to copy a file with a specific size, it will be divided into chunks and it will be distributed onto multiple nodes in the cluster. It is distributed in the sense the file will be distributed onto multiple nodes in the cluster. It is resilient, which means that even if one or more nodes or few of the nodes are down, still you will not have any data loss or any impact for your applications because it is both resilient and fault tolerant. Okay, now we have already set up the HDFS. We have configured slaves and masters. The slaves are data nodes. Okay, so if you go here and if you click on HDFS here, so we have 3 data nodes, 1 name node and 1 secondary name node, and you can click on this data node and see what are the instances that are having the data nodes. It's node 02, node 03 and node 04. Similarly, you can click on this one to see which instance is having name node, and this one for secondary name node. Okay, so this is the typical configuration, and configuration files I have already shown you as part of the previous video. We have done the validation also, and now we will go to the next topic called files and blocks. Okay, so first we need to understand file abstraction, the concept of file abstraction. So file abstraction means that a given file can be larger than one hard disk in any one hard disk in the cluster. For example, even if you have 10 terabytes of storage with one disk of one disk of size each 1 terabyte, then your file cannot be more than 1 terabyte in typical hard disks. Even in my Mac, I have 512 GB SSD, and my file cannot be greater than 512 GB. Even if you have multiple SSDs that is more than 512 GB, my file cannot be more than 512 GB in a typical scenario. File abstraction means the files are typically logical and internally they will be stored in some form, for example blocks, and the file will be distributed across multiple hard disks in the storage server. By doing so, a file can be larger than any hard disk in the cluster. If you have 10 terabytes capacity, the file size can go up to 10 terabyte. If you have 100 terabyte capacity using hundreds of hard disks, your file can go up to file size can go up to 100 terabytes. Okay, it can be achieved by network file system, as well as HDFS. HDFS works in a different manner, and network file system works in a different manner. You will have a rack of hard disks, and there will be a software which will be providing that capability of file abstraction on network file system. In HDFS, it is inbuilt that the file will be divided into blocks, and those blocks will be distributed on the cluster. So HDFS and other distributed file systems typically uses local file system over network file system. So if you configure HDFS or if you configure Cassandra or any other distributed technologies, the underlying file systems will typically use local file system. Okay, it helps us in achieving something called data locality, which I will be explaining later. But just remember that HDFS uses local file system over network file system. It works with network file system also, but it is not very efficient, because for each and every transaction you have to do network I/O, compromising the data locality. Hence, network file system is not very efficient when it comes to HDFS. And files are distributed on HDFS based on DFS block size. So whatever the block size is, based on that, the files will be distributed on multiple nodes in the cluster. In this case, we have 3 nodes, 3 data nodes, right? So we'll try to copy a file into this with block size, with the default block size. To get the default block size details using Cloudera, you can click on configuration of HDFS. And search for dfs.blocksize, and you can see it is 128 MB. Okay, now let me try to copy a file of approximately 300 MB onto HDFS, and I will show how it behaves. So right now I am on my Mac terminal, and there is a file called largedeck.txt. I am searching for the file. So I will take this one. It's approximately 3.5 MB after compression. Before compression it is much larger, and I will copy this file onto my cluster. So this is the path, and I am connecting to node 01, and I am trying to copy it to the home directory on the node 01. So now I am SSH. I am connecting to node 01 using SSH as root. So SSH root at node 01 and ls-ltr, and we can see this largedeck.txt.gz file. So let's gunzip this file on the node, and it will be approximately 700 MB file. Okay, so now it's on the local file system of node 01. Now I will try to copy this file into one of the directories. So first I need to create a directory, because root cannot directly create the files into HDFS. First we need to create a directory in HDFS where root have access. So I am doing that. Hadoop fs mkdir is the command to create the directory. You don't need to worry at this time, you will understand all these commands later. So I am creating something called /user/root, and also I am trying to run another command, Hadoop fs chown root :root /user/root. Okay, so if you are following and if you want to do hands-on at this time, 1 minute. So if you are following my videos and if you are trying to execute, so just type this command without worrying about what is happening under the covers, and just have a directory. Here it should be minus small p, not the capital P. Okay, so now we have created a directory called /user/root, and then modified the permissions on only root, /user/root, not on the /user, to root:root. And now you can say hadoop fs -ls /user and hit enter. So before copying the file, you need to make sure that you have the directory like this with the owner as root, and owner have read write execute permissions on the directory. Only then this will work. And this is the directory in HDFS, not on the local file system. If you try to do ls -ltr to access the local file system, and if you try to run the command ls -ltr /user/root, it will not work. Okay, because this /user/root is HDFS file system. The only way to access that is by using hadoop fs commands, and -ls is to list the files in that directory. And as of now we don't have any files, hence it is empty. Now what we will do is we will use a command called -put, hadoop fs -put, to copy this largedeck.txt file into HDFS. And while doing that, we will also use a parameter, we will also try to override a parameter called dfs.replication. So there is a parameter called dfs.replication. I will explain the significance of it in a moment, but for now we will try to set this parameter to 1. Okay, so hadoop fs -put -d dfs.replication equal to 1, and I want to copy largedeck.txt. So if you want to override any parameter at runtime, you can do it by using -D largedeck.txt /user/root and hit enter, and the largedeck file will be copied to /user/root. I think this I have to put before -put. Yeah, so this is the command. And now the file is copied. So what is the size of the file before copying? It is approximately 720 MB, and we copied that file into HDFS. Now what you can do is you can go to NameNode UI. This is available with all the distributions. This is actually from plain vanilla Hadoop. So even if you don't have any distribution, you should ask the IP address of the NameNode, and 50070 is the port number. Everyone can access the HDFS, and you can click on utilities, click on browse the file system, and we have the user directory, root directory, and we have a file called largedeck.txt, and you can see that the block size of this file is 128 MB, and the size of the file is 693 MB. And if you click on the file, it will show the metadata of the file. And if you look into the details about the metadata, you can see that you have the blocks from 0 to 5, which means 6 blocks, because we have 693 MB. So this, you have to divide that 693 by 128, and you have to seal it. So 693 by 128 is 5 dot something, and if you seal it, then it will be 6 always. So even if it is 600 MB plus 1 byte also, there will be 6 blocks for your file. Okay, so in this case there are 6 blocks for this file, and you can see that all the blocks except block 5 is 128 MB, block 5 is 55 MB. Other than that, everything else is 128 MB. Okay, and you can see that there is something called block ID, there is something called block pool ID, and also availability. So the block ID is used to create the file physically on HDFS, and that file will be stored on the nodes that are specified in availability. In this case, this block ID 1073741945 exists on node03.itversity.com, and you can go to node 3 by saying ssh root at node 03, hit enter, and then go to cd-dfs. So this is the location where the data node directories are created. Again, if you want to know the value of it, you can search for data or data.dir. So this is the location where those blocks with that block ID will be stored. Okay, cddn and lsltr, find name, enter, and you can see that there are two files. One is with the block ID blk underscore the block ID, and then other one is with dot metadata extension. And this block ID will be unique for all the blocks across all the files. So once a block ID is assigned to a block, it will not be assigned to any other block for any other file. So it is completely unique across all the files, not just one given file. Okay, so this is what block is. A block is nothing but the lowest granular size which is used to store on data nodes. Okay, and if you want to get the details about the file, you can come back to node 01. You can run this command from any node. There is a command called HDFS fsck. We have to give the path. The path is user root largedeck.txt and files blocks locations. So files will give the file names under that path. Here we are directly giving the fully qualified path of the file. So there will be only one file. You can get the details about the file name here, and then you can get the block details, and then you can also get the location of that block where that block is physically stored. So now we will delete this file, hadoop fs rm user root largedeck.txt, and again we will copy the same file, but this time with dfs.blocksize 64 MB. So let me calculate the size accurately. So bytes, kilobytes, sorry, megabytes, and then into 64. Sorry. So 1024, it's a KB and it's megabyte, and then 64, so 67108864. So 67108864. So now I am giving the 64 MB as the block size and hit enter. Now the file will be copied into HDFS with 64 MB as block size. So now it is done, and you can refresh this page. You can see this largedeck.txt. Now you have 11 blocks because 693 megabytes into 693 megabytes divided by 64 megabytes will be approximately 10 point something, hence it will be 11 blocks, and the last block will be of lesser size compared to the block size, because whatever left over will be stored in there. So it is very important for you to understand this, how the files will be stored in the form of blocks. Okay, so that's about the files and blocks. HDFS is so again, why we have to, so far as part of the files and blocks I have just covered how the files are divided into blocks. As part of the next video I will talk about this slide about fault tolerance using the same concept of files and blocks plus the replication factor. In this video also I have shown you the dfs.replication parameter, but I haven't explained the relevance of it, but as part of the next video I will cover it. That being said, I hope you are enjoying the content on the channel. If you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to discuss further about certifications or big data, please join my LinkedIn group called ITversity-certifications or ITversity-big data. And finally, if you are not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.